All right, the recording has started. Welcome everyone to week 8. Good question to do an exam review. So, to extract all data from table employees, what keyword is used? Anyone want to guess? Select. Good. What keyword is missing below? Create table employees, ID serial, primary key. Primary key. What keyword is missing to determine how many rows are in the table employees? Select count. Star from employees. What is the missing keyword that was required to make this SQL valid? Select state, max population, max is an aggregate, from employees. Group by, good. Consider the following schema. Books has an ID, a name, an ISBN, and an author. Which query would display a list of unique authors? Select distinct. Good. Which type of join is not valid? This got a lot of y'all. External is not a valid join. A natural join is a thing, an inner join and outer join is a thing. We didn't talk much about a natural join, but it's a thing.
Is that a self join?
No, it's a thing the database can do when you have a primary. It's either a primary and foreign key relationship. It knows that relationship exists, or it's the same column name. I always forget, but it's one of those two.
I'll be right back. Sorry.
Question 7. Given the following table employees, write a query to get the earliest start date of all employees in Maryland. Now, I know this is one of the ones that y'all are asking about, right? Because half of you did it right, half of you did not. So, how would I get the earliest start date of all employees in Maryland?
We need to sort them.
Do we?
You would do select min start date from employees where state equals empty.
You specified in your comments that we might need also select state in order to. Oh no, that was the next one, right?
Yeah, that was a different one.
That was the next one. Sorry.
Yep. So yes, this is the, in my mind, the simplest way of doing this. What a lot of folks did was select start date from employees. Some people missed the Maryland part completely. Order by start date ascending. And yes, that returns the list of start dates in an ascending order. But the question was the earliest start date. And so this... Hold on, one at a time.
Alright, this is Melody speaking, and to my memory, if my memory serves me right, I think during the test you said that either way would be acceptable.
I didn't answer it this way, but it would be fine if somebody ended that with limit 1, correct?
Limit 1, yes, and a couple of you did something like that. So, if I have a clause limit 1 at the end of this, that will return only one row, and that would be the right answer. And had you done that, I should have given you credit. If I didn't, email me.
Professor, I wish I added the limit 1. It just got out. I didn't think of it right off the bat. I basically put in select star from employees where the state is Maryland and order by start date ascending. So what I got out of it is basically you can tell which one is the first one just when you sort it by ascending order. But I didn't think you wanted one single query, the return of one single query.
Yep, and I gave partial credit, but I didn't give full credit.
Yeah.
Professor?
Yep.
Ascending is by default, right?
Oh, is it? And it might be. It might be. So, but I was looking for a singular value being returned.
Hey, Chris.
Yes.
So if you put limit, how are we gonna know like it's gonna give us the earliest date? It might give us the other date too, right? Because there are two employees, I think.
Well, if you sort it and then limit, the first record before you limit would be the sorted
The
value.
earliest one?
Yep.
In ascending and the limit one, you said. Okay,
Correct.
Gotcha. Thank you.
Write a query to get the maximum salary for all employees. Again, I was looking for the same thing. But if there was a sort and a limit, then I would have given full credit for that. But just the sort alone, I gave partial credit again. Average salary by state. How do I do this one?
Select state, comma, average salary, and then from employees, and then group by state.
Yep. So that is the expected and correct answer for that question. Anything different from that would have had a partial credit.
Yeah, it's a little bit different when you don't have access to Postgres right on the spot to check your code.
Yep. Oh yeah, but syntax. If there was syntax issues, I wouldn't have taken credit off as long as it was close.
I get it. For number 8 personally, I put in like a group by statement, and your way is way simpler. I guess.
Yeah, there's nothing to group by based on the what I was looking for.
Gotcha.
But I think that being mixed in with the 2 group bys probably threw some people off.
Yeah, I was more under the impression that if you put in like a function such as max, min, average, you have to put in a group by statement to accommodate. But I didn't know. I didn't realize you can actually just keep it as is and select it from the table.
Yeah, if you don't have an explicit group by statement, you're effectively grouping by the whole table.
Chris,
Yep.
Please do a favor. Can you go back to the question 8? So for this one, if I select name and then max salary, would it return answer or no? Error?
No, that let's see. If you did select name, max salary from employees, you'd have to group by name, but that would return every name and the max salary with that same name.
So what if I want to know the max salary, at the same time I want to know what salaries belong to which one? I want to know the name as well, like all the details, not just the max.
Great. Select. No, it's okay. Select. Let's just start with name, max salary. This is one way to do it. From employees, group by name, having salary equal max salary. Something like that would work.
All right. And for this question number 7, because I remember, probably I'm not right, but I remember you said during the test that either way would be acceptable if you are going to sort it or use the mean version.
I would have to know exactly what I said to change my opinion.
It's okay. You will take to like partial credit, right?
I did give partial credit for the second for this.
All right. I think that's satisfying. Thank you very much.
All right. The update command can be used too. Yeah, I realized we didn't explicitly talk about this one. But the update command is just like a select statement. It's just changing the table, so you can have a where clause and all that kind of good stuff with it. So it can update the data of a field in all records or a field in a selected record.
Professor?
Yep.
If you have selected just one, do we get any partial credit for that? I selected only the first one because update means it will update all the records in the table. Only with a condition or a where clause it will sort out. Since there was no condition there, I selected only the first answer.
I will look back and see if I did, and I will think about if I'll do anything about it. I might.
Thank you, Professor.
It's a great request.
Thank you, Professor.
What does SQL stand for?
Structured
query.
language.
You know how fun it is coming up with other full names based on an acronym? It's like making stuff up like that. Which of the following commands is used to access data from a table? Select. And I realized now I had select and extract. The verbs, access and extract, but it's the same thing. What does a tuple refer to?
Row.
A row. What does RDBMS stand for?
Relational database management system.
Yeah. The primary key of a table referenced in another table is called a
Primary key. There is no unique key.
Foreign key.
foreign key.
Oh, sorry.
Yep, foreign key. Because the key was referenced in another table. I need to update the email address of an employee whose ID is 200. Which statement is correct?
The last one.
Update.
The last one, correct?
Yeah. Here it's primary key.
What is the term used for the unique identifier in a table?
Primary key.
Primary
I
key.
don't know why I marked unique key there.
It happens. It happens. Which query lists all sales managers in Boston?
First one.
Last.
Select.
Yep. Sales manager from Boston. Which of the following statement would be used to insert a new row into a table?
Update.
Insert.
Insert. I kind of gave it away too, didn't I?
Yeah.
Which query will delete the record of the employee with an ID of 100?
The third one. Delete from employees where ID is equal to.
I got some of y'all with this one.
No, it's a integer, so it should not come within the inverted comma.
I agree. But I got some of y'all with that one.
That was tricky.
I didn't miss this problem, but it's not explicitly stated that ID is an integer, and it's possible for a primary key to be an integer.
But you don't make a string in SQL with a double quote.
Numbers.
So this one was wrong for more than one reason. Fair?
Yeah,
What's the end of the reason, Chris? The first one is the string, the quote. The
S-
second?
Yeah, strings are in single quotes.
Oh, that's right.
And IDs by convention are typically integers. Not guaranteed, but typically. I'm designing...
Just being facetious, sorry.
What's that?
I was just being facetious.
Oh, I know. But it's funny, when I made the test, I totally copied my test from last semester. When I made the test, I did that intentionally for that exact discussion. I'm designing a school management system for VCU. It will have the following tables: courses, as an example, Info 610; classes, an instance of Info 610 on Tuesdays and Thursdays, professors and students. What is the type of relationship? Oh, I'm missing a word between, but y'all got that. Courses and classes. Yep, and it's meant to be one-to-many.
Professor,
Mhm.
how is the relation one to many? First, I thought one to many, and then since it was courses versus classes, I said many to many. So, because it says courses, it can be more than one courses.
So in a courses table, we would have every available course at VCU. For instance, Info 610, Info 450, Info 1206. I don't know what the other classes are. Those are the two I teach. Classes are only ever related to one course. Like the class now we are taking, that we are sitting in as of this time we're talking, is Info 610. If this class were somehow a combination of Info 450 and Info 610, then it would be a many-to-many relationship.
Oh, okay, Professor, thank you.
But the same course can be taught by other instructors too, right?
Absolutely, they could be.
But you're trying to say that it's not the exact same this class.
So if we had the two tables, courses and classes, which table would the professor be associated with?
Courses and classes. Classes? That should be courses too, right? I mean, no?
Nope. No, because exactly what you said, many professors can teach a course. Or, let me use the right words, can teach an instance of the course and therefore teach a class. So if you look at a course catalog, the professor is not listed. If you look at a schedule of classes, the professor would be listed.
Right. Gotcha.
Now, if we had a relationship between classes and students, that would be a many-to-many relationship, because at any one point in time, a student can be in more than one class, and a class has many students. There you go, which is exactly the next question. Yep, so this should be a many-to-many relationship. And through all these conversations, you're probably realizing that even I get confused on these relationships sometimes. And the way I work through it is I think about the left table and the right table. Where does the foreign key go? So if my left table is courses, my right table is classes, where does the foreign key go? The courses primary key is referenced on the classes table, so the foreign key is on the classes table, but there is no reverse relationship from the courses table. So that's a one-to-many in that direction. But for students and classes, I can't put a class identifier on the students table because the student has to be in more than one class. I can't put a student reference on the class table because there will be more than one student in that class. So in that case, I have to have a join table. And then if I have a join table, it has to be a many-to-many relationship. So I kind of have to think about it both ways to get the right relationship. That's my point. And then you're a consultant hired to build a database for Mike's Bikes, a local retailer, etc. Describe to me the overall process of your engagement with the proprietor. What I was looking for here, and I would say I think everybody nailed this one really well, with a couple of nitpicks here and there. The general process of you show up, you talk to people, you interview people, you figure out what their current data processes are, you figure out what data they need to track, you design the data, you show them the design, and you build the database, and then you cash a check. Like it could have been that simple. But those steps are kind of what I was going for. And then the take into consideration components, I got some really good answers in there. Some of y'all talking about agile methodologies or quick iterations of development, like all cool things in there to pull in from other courses you've taken, obviously. But I think most everybody did that one really well. I think the only missing parts that I saw more than once or regularly was the explicit call out of designing the database before building it. I actually think that's the only reason I took off any points on this one for anybody. If I remember right, which I don't always do. But anyway, so that was the exam. What do y'all think?
I do have a question about question 23.
Which one?
Question 23.
Yep.
You said something about entities and structures instead of fields.
Mm-hmm.
I think you might have took off like 2 points
Yep.
or something.
Yep. So using the terminology we've used, fields are the specific data points on a row in a table. So if I have a table of employees and I have a row representing me, the value Chris in the first name column, Chris is that is a field. That's the data in the field. I was being super nitpicky on that. I think had you said like entity or object or relation or something like that, that would be more in terminology line with what we've talked about.
Chris?
Yep.
You also commented about the primary key. Yeah, in my test. So do we really talk about primary keys and foreign keys with the owner?
When you're data modeling, it is important to figure out what makes something unique. And so if I were a consultant talking to the business owner, Mike, no, I would probably never mention primary or foreign key. I would talk about uniqueness of people. Because is it first name and last name? No, it's probably not. So how do you derive uniqueness? And then I wouldn't say foreign key, but I would talk about the relationships. Like, so this person can have multiple sales in a day. Awesome. And I translate that back in my design as a primary and foreign key.
Gotcha. Thank you.
Any other questions on the exam? And I'm certainly open for discussion over email if you want to talk or nitpick or try to get some points back on something. I'm fallible, so I can make mistakes when I'm grading. So totally call me out on something if you want to, and we can have a discussion. All right, let's get to the material for the night. If I can find it. Yep.
One last question. If you count all the marks, it's coming to 98, Professor.
Did it?
Yeah.
Uh-oh. I think then everybody might have gotten 2 points for free. Thank you for calling that out. I will look at that after class as well.
That's exciting.
All right. So tonight we're going to talk about transactions in a database. So we'll go over this in detail. We'll talk about what they are and why we have them. But a couple of definitions up front. There's a concept called the ACID properties of relational database. ACID is an acronym. A transaction is a unit of code or a unit or a set of instructions to your database. It can be one or more instructions to your database. And a transaction in a database system must maintain ACID properties in order to ensure accuracy, completeness, and data integrity. The ACID, what ACID stands for is atomicity, however you pronounce that word. Consistency, durability, and isolation. We'll go over those in detail. That word, atomic, I don't know how to pronounce that word.
Atomicity.
I don't know. It's where does the enunciation go? That's the part I can't figure out. This property states that a transaction, which think about is multiple statements in your database. So inserting 4 rows or affecting 4 tables at one time. So that multiple conditions should be treated as one. So when we think about making those changes to our database within a single transaction, all of those statements must succeed. If any of them fail or are not executed, none of them can be executed. So imagine I have an application where I'm onboarding a new employee. I have to insert their employee record. I have to insert their salary record. I have to insert their tax information and their home address in 4 different tables. I do those 4 activities together as one transaction. If any of those fail, none of them can happen. They all have to be canceled. The reason, and so because of that, there should be no time when a transaction is partially completed. So it's either all or nothing. So states, so the state of the database beforehand must remain the same if that transaction fails. So that's what the atomicity, at that word. Atomic means the whole thing has to happen as one. Consistency. I like how they used a circular definition here. The database must remain in a consistent state after a transaction. Meaning no transaction should have an adverse effect on the data residing in the database, unless that's the point of the transaction. So if the changes in the database in the transaction cannot affect other data outside of that transaction. So if I'm inserting into my employees table, my address table can't get messed up, or my relationships cannot be broken with my primary and foreign keys. So if the database is in a consistent state before the transaction, it must remain in a consistent state afterwards. Consistency is data integrity. Durability. The database should be durable enough to hold all of its latest updates, even if the system fails or restarts. If the transaction updates data in the database and commit is how you finish a transaction, then the database will hold the modified data in the case of a failure or a restart. If a transaction commits but the system fails before the data could be written to disk, then all data will be updated once the system springs back into action. I either took that out of the book or made it up. But this talks about the data that you think you're changing in your transaction. If the database system tells you your transaction has committed successfully, then that data is stored forever. Even if there's an immediate failure, even if there's a power outage, even if the disk explodes, assuming you have good redundant disks. But that means that once the database tells you your data is stored, it will be stored. And isolation. So if we have 2 systems working on a table at the same time, and they are each executing transactions, they cannot overwrite each other, they cannot get intermingled. One will happen atomically, the second will then happen atomically. The way the database does that's a really hard concept to think about if you're thinking about a very large distributed database, or even a local database with multiple connections or multiple applications changing data. But what the database engine does is it has basically an internal scheduler to handle those transactions in an order. It's not a matter of which one started first or came first. The database engine takes care of how to deal with multiple transactions affecting the same thing at the same time so they don't collide with each other. So it's a serial schedule. Serial means in a line, one after another, as opposed to parallel execution. All right. So we've talked about transactions a bunch without telling you what it is, kind of. But if we think about a transaction as a series of changes to a database, and a transaction is a unit of control within the database, that unit of control or that transaction has multiple states. So if you're familiar with a state machine or a state engine or whatever word we want to use, the transaction has a life cycle of states that it follows. So at first it's an active transaction. As it's working, the multiple statements, the multiple update statements or insert statements happen, and as they're happening, the transaction is in a partially committed state. If all goes well, then the transaction gets committed with all those Atom properties being met, and then the transaction is done. So the top row, active to partially committed to committed, that's the happy path. If things go well, that's the order of operations or order of states. If things go wrong, then the transaction can get the transaction is created, it becomes active. If something goes wrong, it can move to a failed state immediately. It then goes to an aborted state to finish. Like the aborted and committed states are the terminal states. As a transaction is partially committed, a failure can happen. That transaction gets rolled back in a failed state, and then it's aborted as well. So does this state diagram make sense?
Yep.
So an active transaction is being executed. It's the initial state of every transaction. Partially committed, we have 4 statements. We've executed 1 of them, 2 of them, 3 of them. We're still in that partially committed statement. We can still roll back. Rollback is the key word for canceling or aborting a transaction. Failed, something went wrong. This is typically done, or this is a state we'll typically get into if we violate a foreign key constraint or some other privileges or rights within the database. Maybe we miss a constraint on a data field, whether it's a relationship constraint or a data validation constraint. Something happens that causes this partially committed transaction to fail. And then aborted. This is the stage in the database. You can't see the picture; it rolled off the bottom, but it's the same picture. This is a state this is when the database is cleaning up what happened. So if you were in a partially committed transaction, the database had to know the state of the database before you started that transaction, so it can roll back to what that was. Committed means it's done. We're all happy. So in Postgres, here's some examples. Consider a bank database that contains balances for various customer accounts, as well as total deposit balances for branches. Suppose that we want to record a payment of $100 from Alice's account to Bob's account. And in a super, super simple world, it looks something like this. The first thing we would do, we would update accounts, set balance equals balance minus 100, where name equals Alice. We have just deducted $100 from Alice. Got it? Next step, update branches, set balance equals balance minus 100, where name equals select branch name from accounts where a name equals Alice. That's an awful statement, but the idea is now we are also taking that balance away from that branch. Branch being the Wells Fargo on your corner. Then, since we were transferring that money to Bob, we have to give it to Bob. update account, set balance equals balance plus $100, where name equals Bob. And then we add it to the balance of the branch where Bob banks. So we take it out of Alice's account and Alice's branch, and we move it to Bob's account and Bob's branch. What happens if something breaks after line 2? So we were able to deduce $100 from Alice's account. We were able to reduce the balance of the branch by $100, but then something goes wrong.
This amount will be missing.
It won't go through.
We'd be missing $100 because we never put it back somewhere. This is if we did not do proper database transactions, right? If we just executed these 4 commands on our own serially, because we have a very old database that someone is using SQL Developer by hand to change balances. That'd be a really bad thing, but that's what this looks like. So if that
Wells Fargo was slow, but like
yeah, right. That's why Wells Fargo is so slow. But that's a really bad scenario, right? Alice is out of money. The branch is out of money. Where did it go? It just disappeared. It's like Bitcoin. They just disappear. So now we have no idea. We've lost money. So what do we do to fix that? Hey, it's like I've read these slides before. So we have some commands within SQL. So far, we have written very like 1-line commands at a time, right? We're inserting a record into a table. Cool. As applications get real and get more complex, these transactions hold multiple commands. They affect multiple tables in a database, as this very poor example shows us. And so we use the keyword begin to start a transaction. That keyword begin puts us at that started state of the transaction. Let's see if I can pull this up too. There we go. So we use the keyword begin, and we are now in a transaction in the active state. Rollback, which is not on this example, is how we can intentionally fail that transaction. So if there's a keyword rollback, which we can execute in our code, which will put the transaction in a failed state. We would use that if we are doing data validation or some rules checking in our code if we were doing like a stored procedure typically. We'll talk about stored procedures later, but that's a way to package a whole bunch of code into one, basically a function within the database. So if that function we're writing does some data validation and it says, I'm in a state, or this value is not less than $100 like it should be, we can issue the rollback command to abort that or to fail that transaction. And then the final keyword is commit. Commit finishes our transaction, puts it into that committed state, so everything gets permanently written to the database engine. Begin, do the stuff, commit. If there is a failure in our transaction, in our code, like there's a database error, there's a foreign key constraint error, we don't have to explicitly call rollback. It will happen automatically. If we don't commit a transaction, it gets rolled back. It's almost like exception handling in source code or in Java or Python or whatever.
So what is commit again?
Commit is finishing your transaction. You are intentionally finishing your transaction.
Gotcha. Thank you.
So, hey, look at that. Here's what it all looks like completely, almost. There's another concept in here I'm showing. So same example, but for some reason I changed it to, let's see, we debit $100 from Alice's account, credit Bob account, only to find out later that we should have credited Wally's account. So this goes back to the whole manual Wells Fargo. No, I shouldn't say that. There's another concept called a save point, which we can do, but it'll be a little confusing. Let me talk through it. So in this case, we'll begin our transaction. We will subtract Alice's balance from Alice's account. And because I was smart, I'm doing a kind of a temporary state of the database that I want to remember. And then I updated Bob's account and say, well, no, that was wrong. I'm going to roll back to that save point. Since I'm being explicit to a specific save point, my transaction is still in that partial commit state. Then I update Wally's account where it was supposed to go and commit. Now, if I didn't have a save point here, I don't know why I did this slide in this order, my apologies. But anyway, if I didn't have this save point and I just rolled back, that whole transaction would get rolled back and Alice's account would be back at the beginning balance. So you can have these almost mini transactions within a transaction by using these save points.
So this is the preferable way to do it?
I've never used a save point in my life.
Oh.
It must have been in the book, and that's probably why I put it there.
Gotcha.
Yeah, and unless you're writing like a stored procedure or something, you will typically never actually use the rollback command either. You would have a begin and a commit for a transaction, and if something broke in the middle, it would roll back automatically. Melody, you were asking something?
Yeah, quick question. Because you just said why the book mentions save point, why it doesn't have any practical meaning.
It could. No, I mean it very well could. I haven't used it, but that doesn't mean it doesn't have a reason to be there. Let's see. I think that was the last slide I had. What time are we at? We're at 6:26. So let me pull up a database and show you some practical. So let's go to a table over here and make something up real quick. I don't even need to do that. Uh-oh. Okay, so that's the data in my customers table. So in this case, since I rolled back that transaction, when I select from customers, it should be the $1,000 value. This is where it gets fun. Oh, it didn't return what I wanted it to. Shoot. So here I wanted that to show me at that temporary state the balance would have been 0, but after a rollback, it would go back to 1,000. But I'm sure there's a reason it wouldn't do that. So here I'm explicitly rolling things back. But if I were to try to oops, sorry, I did that. Okay, branches. Customer has a branch ID, int. References. My syntax is always off on this. No, that's not right. Constraint? Constraint. I'll cheat. Explicit. Okay, now I have some data. Tables. Insert into. Thank you. Did I miss any others? Nope, I didn't miss any others. Customers, customers, customers. Branches, good, I have my home branch and all. Why didn't it create customers? Did I mess something up in here too? Serial primary key. Thank you. Foreign. Oh, what am I doing wrong with my foreign key? Oh, it's not foreign key. It's just references. There we go. Okay, I got my branches. I got my customers, and they have the balances I would expect. Okay. So what I'm trying to get to is if I try to break that foreign key constraint, whoops. Is that going to work?
No, customers is not wrong.
Yeah, well, that too. Is that going to work?
No.
No. We'll get a foreign key constraint, right? So I'll just execute that one line. So I get a foreign key constraint. And so if I run this as a transaction, clear, run. My transaction starts. This part worked. I updated the balance to 0. Then in that transaction, I try to set the branch ID to 2, which failed. So when I select star from customers, my balance should be what it was at the beginning. What? This is probably because I'm jumping around and messing things up. Current transaction is aborted. until end of transaction block. What the heck? How the heck do I fix that? You can see it got into a weird state and it failed. Do I have to roll back explicitly? Do I have to commit? This usually happens in a store procedure, so this usually just happens magically. Anyway, so my balance is what it was at the beginning. But if I take that out and don't cause the failure, PL/SQL procedure successfully completed, my customer balance should now be 0. So that's the point of a transaction, is to protect that kind of error from happening after partial or after some success. I'm gonna grab my book while I'm thinking. Any questions about the concept of transactions or why we use them? I have a question on the syntax right there, but I'll figure that one out. Somebody say something?
You said it's good to use this if we're updating, or I guess if we're inserting information in multiple tables at once.
Yeah. Yeah, or even changing multiple rows in multiple SQL statements. It's multiple SQL statements is really when you use it.
Professor, I have a question.
Uh-huh.
So this time you don't use the save points, but why this when you roll back it updated the balance?
So the save point was almost a mini transaction within the bigger transaction. So if I were writing more complex PL/SQL, then I could do if statements, and if this worked, then great. Otherwise, I could do an else statement where I did another thing, and around this I could do a save point because I still want this to happen, because I can basically handle my own errors if I know they're going to happen. So here I would do a save point at the beginning. If this failed, I could do a rollback to that save point, and then I could do this to try to fix it or something like that. Yeah, see, even in here, all the transaction stuff is around a store procedure. We'll talk about store procedures next week, because that's going to be way more fun.
Hey, Chris.
Yep.
Do you mind drawing the statements on the slide too?
Say again?
Do you mind throwing these SQL queries or these statements in the slide?
Oh yeah, absolutely, absolutely. I will.
Thank you.
Yep. I will link to them somewhere in there, or I'll put them on the main page. I'm still gonna try to figure this one out. Oh well, I'll look it up later. Is anyone stuck? Actually, I'm gonna hit stop real quick.